Now let's move on to the next chapter 2, which is motion in one dimension. Under this chapter we will have 3 lessons or 3 topics or sections. The first section is what is the relationship in displacement, distance, velocity, speed and average speed. Here we will see distance, displacement, which is a vector physical quantity, speed and velocity. Under section 2 we will define the meaning of acceleration and solve some examples related to acceleration. Under section 3 we will see falling objects. Why do objects fall down? Why do objects return back once they are thrown vertically apart? So objects, they return back if they are thrown vertically apart. Once they reach their maximum height, they will return back. So what is the cause for the returning back of these objects? So why do objects return back to their throwing point if they are thrown from this point? So why are they returning back after reaching some maximum height vertically apart? So what is the cause or what is the force responsible for the returning back of this object? Or why do objects fall down? And what is the reason behind? So that's called gravity. A gravity is a force, gravitational force is a force that pulls objects vertically downward. So these are the 3 lessons or sections that we have under this chapter. Now let's move to the first section, that is displacement and velocity. What's the displacement, what's the velocity, and what's the relationship? Under this lesson we will see the relationship between distance. How are distance and displacement related? Distance and displacement, the relationship, the similarity and their difference. And what is the relationship between speed and velocity? And we know that these 2 physical quantities are vectors. Displacement and velocity are vector physical quantities. They are vectors. Vectors, we mean that they have both magnitude and direction. Vectors are physical quantities which have both magnitude and direction. Whereas distance, these 2 physical quantities, they have only magnitude. We don't care where they are going, or what we need is the amount, the magnitude or the number. And they are called scalars. They are called these physical quantities are called scalar physical quantities. The scalars are quantities which have only magnitude but not direction. Whereas vectors are physical quantities which have both magnitude and direction. So whenever we are talking about displacement and velocity, we need to know the terms motion, frame of reference and others. So let's define what the meaning of motion. Motion is the change in position. Relative to a fixed point, called a reference point. We'll define what reference point means next. Motion is defined as the change in position relative to a reference point, and it always happens all around us. This motion happens around us. There's always motion around us. And there are two types of motion. Actually, there are two types of motion. That is one-dimensional motion and two-dimensional motion. Motion along a straight path or a motion that follows a single path is called one-dimensional motion. For example, when we have a car moving along a straight line. If you have a car, if the car is going to the right, this kind of motion is called one-dimensional motion. Or if you have a ball which is moving vertically downward, these are one-dimensional motion. And the second kind of motion is two-dimensional motion. A two-dimensional motion is a motion which has two components. And the best example is projectile motion, inclined projectile. When an object is projected, it will follow this kind of path. This is called trajectory, with some initial speed v0. So one-dimensional motion is this is a simple type of motion. This is the simplest form of motion. It's easy to handle, and it's called, that's why we call it the simplest form of motion. It's a simple form of motion. Now the next is, what is the meaning of frame of reference? What does it mean? So when we want to talk about the motion of an object, we need to have a frame of reference. We need to have, or we must know what a frame of reference means. Frame of reference is, it is a fixed convenient point. It should be fixed convenient point against which we can measure the change in position, or we can measure the displacement. So a reference point or frame of reference is a convenient, fixed convenient point against which we can measure the change in position, or we can measure the displacement of an object. Let's see example of one-dimensional motion in terms of a frame of reference. The motion of a commuter train traveling along a straight route or path is an example of one-dimensional motion. See, each train are going, this train is going forward and the other one is returning back. So each train can move only forward or backward along its track. It will follow a single path or track. So this is an example of one-dimensional motion. A train moving along its track is an example of one-dimensional motion. So, like as I told you before, one-dimensional motion is a motion in a single line or in a single track. So, motion of the object or motion of a train or a car along a straight path is an example of one-dimensional motion. Or the falling down of an object from a certain height. So these are examples of motion in one dimension. We can list a lot. These are the typical examples. Now let's go. Whenever we are talking about motion, we mean that the object is changing its position. So whenever it's changing its position, we will have a term called displacement. So what is the meaning of, let's see the meaning of displacement relative to motion. So whenever we talk about displacement, this is a change in position. Displacement, an object, if we say an object is moving or displacing, we mean that it is changing in position. So displacement is defined as the change in position of an object. So when you say an object is moving, it means that it has displaced some distance. It has covered some distance. So, like for example, if we have a car which was initially at point, let's say we have a car or a train or any moving object which was initially at this point. So if this car moves forward from point A to point B, we say that the object is moving. So this straight length or this straight path is called displacement. The straight path along the x-axis or this length is called the displacement of the car, or the total distance covered by the car along the given direction. So this point is called the initial point where the object starts movement, and this is called the final point where the object stops moving. So xi is the initial position and xf is the final position. So the car is changing its position from A, that's xi, to a final position B, that's fx or xf, final position. So displacement is mathematically expressed by the formula delta x, which is a difference between the final position and the initial position. And this is kind of triangle, which means delta. It's called delta, that is change. So this triangle is called delta, which means the change. So the change in position, that's delta x, which is defined as the final position, that's xf, minus the initial position, which is xi. That's how we define the displacement of the object. Now let's see example how to find the displacement of the object. Here, as you can see in the figure, this Jeko is traveling from or moving to the right from some initial position xi to a final position xf. So a Jeko is moving along the x-axis from the initial position xi to a final position xf. So we want to find the displacement of this Jeko. So as you can see from the figure, the final, let's see this final position. How much is it? It's like, it looks like it's 85. This is 85. This is like kind of 25. It looks like it is like 25 or 22. This is 22. So the displacement of the Jeko, that's change in x, which is defined as the final position minus the initial position. As you can see from the figure, the final position of this Jeko is 85 centimeter. Assume that the measurements are given in centimeter, minus the initial position is 22 centimeter. So the difference of these two numbers will give us, you can use calculator, but it's a simple mathematics. The numbers are small, so we can use mental maths, which is 63 centimeter. This is the displacement of the object. So the object, or this Jeko, has displaced a distance of 60 centimeter to the right. We can add, if you like, if it's necessary, we can add right, because or to the direction of positive x-axis. This Joko is moving or traveling to the direction of positive x-axis. So the displacement of this Joko is given by 63 centimeter to the right or positive x-axis. Now let's see another example. Here, in this case, we want to see the similarity and difference between distance and displacement. But don't forget that displacement is different from distance. Sometimes they could be the same, but displacement is not always equal to displacement. This is very important point. Some students get confused with these terms. So, but here, displacement, I want to show you the difference between displacement and distance using this example. Let's see this Joko now. The Joko is climbing up a tree. Okay, so the Joko starts climbing the tree from 20 centimeters from this distance. This is the initial position from a distance of 20 centimeters and travels vertically upward to a distance of 8 centimeters. So in this case, for this particular case, what the displacement of the Joko? Here we have 3 cases. This is very important. In this case, when this Joko is traveling vertically upward from a distance of 20 meters to a distance of 80 meters, so the displacement, or here we can use delta y. Because the reason why we are using delta y is because the Joko is moving vertically upward along the y-axis. So whenever the movement is along x, we have to use delta x. But if the motion is along the y, we have to use delta y for displacement. So the displacement of this Joko is the final position, that's y final, the final position, minus the initial position of the Joko. So the final position of this Joko is 8 centimeters, and the initial position was 20 centimeters. So in this case we will get 60 centimeters along the positive y-axis. Don't forget that the Joko is moving vertically upward. As you can see from the figure, this Joko is moving vertically upward. So here we can add the quantity vertically upward. So in this case we can use an upward because the Joko is moving upward. Up. Now let's see the second case. Look here, in this case the Joko was moving from a distance of 20 centimeters to a distance of 8 centimeters. Once it reaches at 80 centimeters, it returns back to a distance to runs up the tree from the 20 centimeter marker to 8 centimeter marker. After that, it retreats down. Look here, once it reaches 8 centimeter, it is retreating back to 50 centimeter. Now, Joko is right here. Is retreating. Here is the Joko now. So, we want to find the total distance and the total displacement of the Joko. Now let's find the distance. Now the distance traveled, the total distance traveled by this Joko is, let's calculate the total distance. Here, as I told you before, distance is a vector, a scalar quantity. It's not a vector. It is a scalar quantity that doesn't need any direction. What we need is the magnitude, the number. So the total distance while it is moving up is from 8 centimeter minus 20 centimeter. That is 6 centimeter up, plus when it retreats back, like it's retreating from 80, from this, let's find this one, that is 8 centimeter minus from 80, it's retreating back to 50 centimeter. It will be 30 centimeter. So vertical upward, it has traveled 6 centimeter, and retreating back 30 centimeter. Totally it will be, then the total distance traveled by the Joko is 90 centimeter. We don't care where it's going, whether it's moving up or moving down. What we want is the total distance. So while it's moving up, it has traveled 6 centimeter. When it's retreating back, it has traveled 30 centimeter. All together, we get 9 centimeter. Let's see the displacement. Let's find the displacement of this Joko. Now, here comes the difference. So whenever we are talking about the displacement, we have to take into account the direction of the object, or the initial and the final position. That is the final position minus initial position of the object. So the displacement of the Joko is given by, now we have to, it's better to use y because the object is moving vertically upward. The Joko is going up, so instead of this I have to use change in y, which is given the final position minus initial position. This case, Joko is right here. This is the final position, that's 50 centimeter, minus the initial position is 20 centimeter. Then it will be 30 centimeter upward. This is the displacement of the Joko. Now we can relate these two numbers, the total distance with the displacement of the Joko. Here the distance is 9 centimeter, but the displacement is 60 centimeter. So from this we can conclude that displacement is not always the same as or equal to the distance.